dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome my dear students to yet another lesson on heat transfer. We have had a lengthy discussion about thermoconduction and thermoconvection. Today we will discuss an experiment to show that water is a poor thermoconductor. Okay, the objective, as you can see, is to describe an experiment to show that water is a poor thermoconductor. Water does not conduct thermal energy well. In this experiment, this is what we will need. So you need a test tube where you will put some ice and water. Then we need a burner, something to provide the heat, and you can use thin wire gauze. This is the ideal setting. You will see later when we are making a demonstration of this experiment. I replaced the thin wire with a weight, something to keep the ice down in the test tube. So you need to come up with a setup like this. Okay? You place your ice wrapped with wire gauze in a beaker having some water, and then you heat the top. There is a lot of logic here. Number one, we are wrapping the ice in wire gauze to overcome the upthrust on the ice. We know that due to density considerations, this ice, if left unhampered, will always float on water. Okay? So, to keep this ice to the bottom, we will wrap it in a wire gauze, or I will use a different approach to keep it to the bottom. Then we always hit the top. We don't hit the bottom. We want to show that water is a poor thermoconductor. So why don't we hit the bottom, but we hit the top? If you hit the top, you eliminate convection currents. There will be no convection currents because the water here will heat up, less dense, and remain at the top. So it can't go down. There will be no heat transfer to the ice by convection. So the reason why we are hitting the top of the test tube is to eliminate heat transfer by convection. So this leaves us with conduction. Now we are also using a glass test tube because you know that glass is also a poor thermoconductor. And your procedure should look like this. Fill the test tube with water and put some small pieces of ice. Make sure that the ice cube is at the bottom. It's very important. Then heat the test tube from the top using a Bunsen burner. Okay? So this is what we need to do. Now, when you do this, you will observe that the water will boil at the top of the test tube, while the water at the bottom and the ice remain cold. And this is a demonstration that water is a poor thermoconductor. We are going to do this experiment next. So let us check. Okay, from our introduction we just had, now we are going to make that demonstration. This is the apparatus we will need. This is a stand where I will put my test tube. Here I have the test tube. I have some pieces of ice here, crushed. This is the Bunsen burner, and I have some water. I will use this weight to help keep ice to the bottom of the test tube, because you know when you put ice and water, the ice tends to float due to concepts of upthrust and density. So let me put some pieces of ice inside. This one is big. I'll use some smaller pieces like this one. I don't need too many, just a few will do, will suffice. So I have put some ice, you know, in the test tube. Then I will put this weight inside to help keep the ice to the bottom. So we have a setup. In our procedure, in our discussion there, I used wire gauze. So you wrap the ice in wire gauze to help it sink. But this will serve the purpose. Then I have to add some water. I think this is enough. And then put the test tube on the stand. Let us put this test tube here. And I hope we have held it firmly to minimize accidents. So you see we have ice at the bottom and some water. Let me even add, because I want to heat to the top. I think that's enough. Now I will light the Bunsen flame and use it to heat the top of the test tube here. The water at the top is boiling, and yet we still have ice to the bottom. So this water at the top boils, we still have ice to the bottom. If you look closely, we still have the ice cubes to the bottom. This is a demonstration that the water and this glass test tube are poor thermal conductors. So from our simple experiment, that very short experiment, we have a question here that tests our understanding of today's topic. You can find this question in your book on page 170, just in case you want to check it up. So we have three situations. A student wants to show that water is a poor thermal conductor of heat. The diagram below shows the investigation he sets up. So you see the first setup in A, he has ice at the bottom. In A, the ice is held to the bottom by wire gauze, and then he heats the top. So here we know there is no thermal convection because he's heating the top. The heat cannot reach the bottom by convection. We are left with conduction, and from our previous discussion we have seen that even the thermal conduction is minimum. So that means the heat from here will not easily reach the ice. Thermal conduction and thermal convection are eliminated. Then here the ice is left without any weight. So as I told you, it floats. So when the ice is floating, you hit the top. No need for convection as well, because you're hitting the ice directly here. It's a small convection, you know. So in this case, the ice is in direct line of fire. Okay. And then we have the third situation in C. You can see that the ice is at the top, and then we have heating at the bottom. Now here there is no conduction. Our experiment has shown us that water is a poor conductor of heat, but there is convection. You see, there is convection. Water at the bottom will be heated, it expands, becomes less dense and rises. So there is thermal convection transferring heat to the ice. Now if we recap this, we are saying here there is thermal convection but no thermal conduction, or the thermal conduction is minimum. Here you have thermoconduction and thermoconvection. And then here, the two are eliminated. So once you put those things under consideration, you can then answer the questions that follow. The student measures how long it takes for each piece of ice in the water to melt. The result will help him to show whether or not water is a poor conductor. State anything the student should do to make sure this is a fair test. Most of the questions about experimental physics, they always test for control variables. So this question is testing control variables. What are some of the things you must keep constant to maintain a fair test? So it's asking for control variables. One of the control variables could be the volume of water you use, the amount of ice you use, the amount of heating. All those things, you must maintain them in order to get a fair test. Then it says, assuming that this is a fair test, in which order do you think the ice will melt? Starting with the slowest. Okay? So if I go back, I think this will be the slowest. You see? Followed by this one, and then this one. This one melts fast because the ice is in direct line of fire. So, you know, there is a lot of it's even touching the test tube, so we expect some conduction to take place. Okay, and the time taken for heat to travel from here to here by convection is definitely smaller than this one. Okay, so this one is the quickest to melt, followed by this, followed by this. But if we are starting with the slowest, it's A, C, and then B. How can this investigation show that water is a poor conductor? I think from our experiment, you could be in position to answer that question. So this brings us to the end of our lesson. See you next time.